Okay, so in this video, we're going to be talking about solving linear inequalities. So linear inequalities in itself is talking about lines with an inequality in it. And inequalities are of the form less than or equal to, greater than or equal to, or just greater than. And there's a whole bunch of different ways to read this. Less than, below, smaller than, and similarly with greater than, above, or taller, or more. Okay. Now, what we want to do is show this linear inequality. And so what we did first is draw the graph. And what we want to do is first learn how to read this so that we can then apply all the solutions and see that they actually come out the way that we want them to. So first, let's read this as line 1. In a graph, can we see pictorially that we want to have it below, not just less than? So below is a nicer word to use. And then the one on the right is line 2. So this question is really asking, when is line 1 below line 2? And in particular, it's for what x value or values. So here's the picture. The green one is line 1, the black one is line 2. Can we see right here, that is where it stops being below and the green line starts to be above the black line. So what x value does this take? And the answer is 3. And can we see also that anywhere to the left of 3, this graph, the green graph, is below the black graph. So our answer is going to be from negative infinity up to 3. And the question is going to be whether or not to include the 3 or not. And this comes from the top over here, where this is actually or equal to. So we can allow this to have an equality. And if you want, this could be below or same as line 2. So what we're going to do now is let's actually take this equation and solve it algebraically, and we should get this same result, the same answer. So let's erase the graph. And what's really nice about linear inequalities, or inequalities in general, when you solve them, basically solve them like an equal sign. So what I'm going to do is I'm going to switch it out and show you that they're actually the same. So let's make pretend that it was like this. So if I subtract 2 to both sides, we get 3x is equal to 2x plus 3. And then bring the minus 2x over. So we get x is equal to 3. And let's just throw the inequality back in. So if you read this, this says x is less than or equal to 3, or it's the x values which are below 3 or equal to 3. And can we see that that's these numbers here, this negative infinity to 3. Now, before we finish off, the last thing to know when solving inequalities is 2 rules. So the first one is when dividing or multiplying both sides by a negative, number, flip the inequality. And number 2, don't multiply or divide by a variable unless you know its sign. And its sign just means whether or not it's positive or negative. So really quickly, let me just change this problem to have something very simple so we can see. Negative 3x plus 1 is less than or equal to 2. So this will give us negative 3x is less than or equal to 1. And in this case, we're going to divide both sides by a negative 3. And this follows rule number 1. So when I divide it by the negative number, we flip the inequality, which gives us greater than or equal to 1 over minus 3, or negative 1/3. So this solution set is going to be the numbers of x which are above negative 1/3, above or equal to negative 1/3, which are those numbers.